There is a hush at the very center of many galaxies, a dim pause before brilliance takes shape. When you close your eyes and breathe in slowly, imagine the dark slope of space unraveling. And in that shadow, something ignites. It's a quiet beginning, but with power that echoes across the cosmos. Tonight we drift toward the luminous hearts of galaxies, toward what scientists call quasars. Picture for a moment a supermassive black hole, millions or even billions of times the mass of our Sun, quietly waiting in the core of its galaxy. Around it, swirling clouds of gas and dust spiral inward, drawn by gravity's inexorable pull. In that spiral, friction and gravity heat that matter, until it glows with unimaginable brightness. This spiraling disk is called an accretion disk, the dinner plate of the black hole, yet it shines more brilliantly than the light of an entire galaxy. What you're witnessing in your mind is the birth of a cosmic lighthouse. Tens of thousands of light years away, matter is falling in, heat is rising, radiation is blasting out. These are the objects known as quasars, active galactic nuclei, whose radiant cores outshine their host galaxies by orders of magnitude. They are, in effect, the brightest beacons in the universe, visible across billions of light years. As you exhale, imagine the spiraling light wrapping around the black hole like a golden ribbon. The jets from the poles shoot out like cosmic geysers, nearly at the speed of light, cutting through intergalactic space with elegant perpendicular arcs. The scale is so vast, one disk may span light years in diameter. Yet the energetic core is contained within a volume smaller than our solar system. But let's soften the scene a little. Feel the slow change in tone, the curiosity turning into tension as we draw closer to that hidden core. The swirling matter is violent in its energy, yet our gaze remains gentle. We do not rush, we linger. We imagine the shimmering radiation, the magnetic fields, the jet streams gently unfurling. It's both fierce and soothing fierce because of the energy released, and soothing because it unfolds with vast patience, a dance extending across millions of years. Now breathe again, let the awe settle. This light you're imagining is ancient. It was born thousands, perhaps billions of years ago, and traveled across emptiness to reach here. In that journey lie stories of growth and transformation of galaxies, merging of black holes, feeding of matter, cycling through creation and destruction. These engines of light carry within them the memory of existence itself. Consider this: every quasar we observe is a window into the early universe, because they were more common when galaxies were young, when collisions were frequent, when black holes grew fast. Images taken by the Hubble Space Telescope and the James Webb Space Telescope show quasars at epochs when the universe was less than 1 billion years old. They are lighthouses from a time almost unimaginable, and yet, despite the ferocity of the physics, something deeply calm permeates this scene. The light does not shout, it glows. The jets do not roar. They whisper along magnetic field lines. The black hole does not scream. It patiently consumes. In that consumption there is stillness, because it happens over eons. Let your imagination drift further. Imagine a quasar in its early adulthood. A galaxy colliding with another gas funneled into the core. The black hole awakening light. Flaring jets blasting outward. Then, after hundreds of millions of years, the fuel dwindles and the quasar quiets down. The glare diminishes. The host galaxy becomes typical once again. The cosmic lighthouse dims, but its imprint, its history remains. In this quiet, you feel a breath of awe. You feel that you are witnessing not just a phenomenon, but a narrative matter, energy, light, gravity, all intertwined. Each quasar reminds us of the dual nature of the universe, both energetic and still both historic. and present both wild and gentle. As we complete this chapter, the energy gradually fades. The golden disk dissolves into the broader galaxy. The jets evaporate into background radiation. You are now floating back ease, returning to the listener. In that exhale, we leave the heart of light and prepare to follow the threads that shape galaxies themselves, how they grow, consume, transform. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. There is a quiet hunger that moves across the cosmos, one that does not roar or blaze but unfolds gently over billions of years. As you breathe in deeply and let your shoulders soften, imagine the great spiral of our home galaxy, the Milky Way, turning patiently in space surrounded by a delicate swirl of stars, gas and dust. And drifting toward it unseen until now is a smaller companion, the Sagittarius dwarf spheroidal galaxy, a faint galaxy caught in a slow gravitational embrace. The Sagittarius dwarf may be modest in size compared to its majestic partner, yet in this cosmic dance it plays a vital part. In the cold hush of space, it has orbited the Milky Way several times, its stars being stripped away, its shape stretched, its identity blending with the larger system. Scientists estimate these close passes occurred about 5 or 6 billion years ago, then 2 billion years ago, and more recently, around 1 billion years ago. With each passage, the Milky Way grew a little more, acquiring stars, gas, and momentum. Streams of stars, once belonging to Sagittarius, now arcing like silver threads around our galaxy, revealing a history written in light. Feel the slow rhythm of this union. The smaller galaxy comes near, is drawn in, sheds its stars and gas, and the Milky Way's halo and disk respond quietly. The stellar streams wind around the galactic core like ribbons drifting in a gentle current. Each star in those streams is a long-faded memory of a smaller world, now woven into the vast tapestry of our home. Observations from the Gaia mission reveal that these stellar ripples and disk perturbations correspond with the timing of the Sagittarius passes, suggesting our galaxy's structure bears the imprint of these cosmic companions. As you exhale, imagine the Milky Way's edge, a broad disk of pale light, its spiral arms stretching outward, its halo shimmering with ancient stars. Now picture Sagittarius falling in, drawn by gravity's quiet hand. It is not a sudden crash, rather it is slow, almost meditative. The smaller galaxy's gas is siphoned off its stars, pulled into long arcs, its dark matter halo blending into the Milky Way's outer reaches. Over time, it becomes part of the grander whole. This process of accretion galaxies growing by absorbing smaller ones is a key chapter in galactic evolution. It tells us that even the great spirals are not static islands. They are living systems shaped by encounter after encounter. The Milky Way is estimated to hold 100 to 400 billion stars, yet many of those stars arrived here through such gentle unions not born in situ. In those quiet mergers, the story of our galaxy's growth is written. Let's soften our gaze now, noticing the poetic echo of this cosmic event. In our own lives, we merge, change, give, and receive. In galaxies too, this same rhythm plays out, but over timescales so vast, they dwarf human comprehension. Imagine the combination of time and motion. Hundreds of millions of years pass while stars complete folds around the Milky Way, while gas cools and new stars ignite, while streams wrap around the halo like whispers of former identities. The beauty is in the patience, the endless drift, the silent accumulation. And yet, even as the Milky Way consumes it, does so without violence in our metaphorical sense. The stars don't explode. They drift into new orbits. The gas doesn't collide catastrophically. It is gently drawn in and ignites. These processes shape the disk and halo, create ripples detectable in star velocities and chemical abundances. In fact, the encounters with Sagittarius are believed to have triggered bursts of star formation in the Milky Way, reviving the galactic engine in subtle waves. The galaxy breathes a little deeper as new stars arise. Imagine now drifting close to one of those stellar streams, a pale arc of stars weaving around the Milky Way, trailing far beyond the visible disk, trembling beneath the unseen pull of dark matter. The stream glows softly in your mind, the stolen stars of a long-gone companion, now orbiting in silence. You sense time stretching. Each star is an echo tracing motion across millions of light years. Yet in this moment you hold the memory. Through this imagery, you begin to feel connected to our sun. Our own star sits within this disk, shaped by ancient accretions and distant mergers. The pattern you are inside is the result of countless slow dialogues between galaxies. Imagine the sun as a quiet observer, riding along one of the arms that grew fuller. Through these cosmic gifts, the memory of those galactic contributions lives in the halo stars above, in the chemical signatures of ancient stars, in the ripples of motion through the disk. Take a slow breath and let the scale sink in billions of years, hundreds of thousands of light years, countless stars moving in orbits shaped by encounters. And in that stillness, you sense the calm power of growth and transformation. There is no crash, no explosion in sight, only gravity's quiet patience, drawing worlds together, weaving them into a larger pattern. Within you, you might feel the gentle hum of belonging, that this galaxy, this home, is not simply a backdrop to your life. It is composed of millions of stories layered upon each other, and one of those stories carries you. As we begin our transition into the next chapter, imagine pulling back slightly. From the detailed view of streams and feasting comes a wider sense of structure. Galaxies, pair they merge, they change their hearts. You will soon drift toward another hidden drama, where two galaxies merge violently, yet slowly orbiting twin hearts of darkness. The vantage shifts from the Milky Way's appetite to a cosmic embrace. There is a place in the universe where silence meets power, where gravity itself hums a steady note, too deep for ears to hear. As you inhale, imagine two galaxies drifting toward each other across millions of light years. They are slow dancers in a cosmic ballroom, their arms of stars brushing softly, their halos of dark matter overlapping their cores, beginning to tug in rhythm. At the center of each one, a supermassive black hole waits, patient and unseen. These encounters are among the grandest spectacles of cosmic evolution. When two galaxies merge, their stars rarely collide. The space between them is too vast. Instead, they slip past one another like waves overlapping in a sea of light. Gas and dust flow inward, stirred by gravitational tides. Spiral arms twist and fold, reshaping themselves into new patterns. At the center of this chaos, the two black holes begin to notice each other, a quiet, powerful attraction forming between twin singularities. Astronomers call them binary supermassive black holes. They orbit one another within the merged core, bound by gravity, but separated by unimaginable distances, sometimes light years apart. With every orbit, they shed a tiny whisper of energy as gravitational waves. These ripples in space-time move outward at the speed of light, stretching and squeezing the very fabric of reality. For now, their signal is faint, so faint that only with exquisitely sensitive instruments like pulsar timing arrays can we begin to detect them. But in the near future, missions, such as the Laser Interferometer Space Antenna, or LISA, will listen directly to the universe's heartbeat, the low hum of merging giants. Breathe slowly. The motion of these two black holes is both violent and serene. Imagine them circling each other for millions of years. One drifts closer, the other responds, their orbits shrinking imperceptibly. The space between them curves more sharply. The stars around them are flung outward, and the gas spiraling toward the pair heats to white-blue brilliance. Jets may flicker from their accretion disks, narrow beams of charged particles streaming across hundreds of thousands of light-years. If you could stand safely at a distance and watch, the scene would unfold at an almost meditative pace. Galaxies take their time. Every rotation, every ripple, stretched across millennia. There is no rush in their collision. What seems violent when imagined in human time becomes tranquil when seen in cosmic rhythm. Gravity performs not destruction, but transformation. Picture the moment of coalescence, the two black holes spiraling inward, until at last they merge. The gravitational waves crescendo, releasing more energy in an instant than all the stars in the universe combined. Yet the light itself may remain dim. In that union, space-time ripples outward, like concentric rings in an invisible pond. The resulting black hole wobbles for a while, then steadies silent once more. The galaxy around it reshapes its stars, adjusting to a new center of gravity. Its heart, now a single, larger presence, a monument to patience and inevitability. There is something deeply human in this slow convergence. We too orbit the centers of our lives, drawn by forces unseen but deeply felt. Sometimes two paths cross-circle and merge into one. The universe reflects that truth on the grandest possible scale. The twin hearts of galaxies mirror the unions that create new beginnings. Now drift closer in your imagination to that merged heart. You cannot see it, but you can sense its outline, a region from which not even light escapes, surrounded by a disk of radiant plasma, glowing as matter falls inward. Time slows near its horizon. A second out there might stretch into years for us. The light bends around it, forming rings of distorted brilliance, a cosmic halo of deception and beauty. Scientists studying these systems search for subtle clues, flickers in light curves, radio emissions that pulse like distant beacons, patterns that repeat with the rhythm of orbiting giants. Each observation adds to our understanding of how galaxies grow, how black holes evolve, how gravity itself shapes the architecture of everything we know. In their data lies poetry numbers that describe motion too vast for any canvas but space-time. Let your breath steady as the imagery fades. The two galaxies, once separate, have become one, a single, massive, elliptical, its dust settling its stars, finding new paths. In its center rests the merged black hole surrounded by calm. What was once a pair of hearts beating in unison is now a single steady pulse beneath layers of ancient starlight. This is the rhythm of the cosmos attraction convergence, quiet aftermath. Each merger leaves behind subtle fingerprints, a faint gravitational hum, a rearranged pattern of stars, a changed story written in light. From such unions come the mature galaxies we see today, serene and luminous, carrying within them the memory of collision. Breathe out and feel that calm returning. We have watched the slow waltz of galaxies, the union of invisible giants, the balance restored after chaos. Ahead lies the next mystery, the unseen scaffolding that holds these galaxies together, the vast shadow shaping every motion. Soon we will turn our gaze toward the invisible, toward the cities made of darkness itself where matter hides and light obeys. There are places in the cosmos where almost nothing shines, yet their presence can be felt everywhere. Places built not from light, but from gravity, silent architectures of the unseen. As you take a slow breath, imagine a vast invisible landscape stretching far beyond the reach of any telescope. No flicker of stars, no glow of gas clouds. And yet this dark domain is what binds the universe together. Astronomers call it dark matter, though the name is a placeholder, a whisper, for what we do not yet know. It neither emits nor absorbs light, and yet it outweighs everything luminous by a factor of nearly 5. Every galaxy, including our own, is wrapped in an enormous halo of this unseen substance, a kind of cosmic framework upon which stars, gas, and dust have gathered over billions of years. Without it, the Milky Way could not hold its shape. Its stars would drift away like embers in the wind. Now, close your eyes and picture the Milky Way as a glowing spiral of light, about 100,000 light-years across. Around that spiral, imagine a sphere of invisible gravity, extending hundreds of thousands of light-years farther still. It is there, though. You cannot see it curving the paths of stars, shaping the rotation of the galaxy itself. Astronomer Vera Rubin, in the late 20th century, was the first to hear its silent call when she measured how stars on the outer edges of galaxies moved just as swiftly as those near the center. If only visible matter existed, those stars should have drifted away. But they did not. Something unseen held them close. This invisible mass, this hidden city of gravity, is not confined to individual galaxies. It stretches across space like a scaffolding of the cosmos, forming filaments and nodes where galaxies gather like dew drops on a web. The Great Cosmic Web, mapped by deep sky surveys, shows clusters of galaxies glowing faintly along threads of dark matter. Between these threads lie vast voids, silent expanses, where galaxies are rare, where darkness truly reigns. Through this network, the universe has built its grand design, a geometry of the unseen, written in gravity instead of light. Let your breathing slow as we drift closer to one of these invisible realms. Some galaxies, faint and ghost-like, are almost pure expressions of dark matter. They are called ultra-diffuse galaxies, immense in size, but with so few stars that their light barely registers even in long-exposure images. The Hubble Space Telescope has captured some of these cosmic ghosts, stretched thin across space, their faint halos tracing where dark matter still lingers. Others are so faint that they contain almost no visible stars at all, gravitational structures, without luminous substance, like outlines waiting to be filled. And then there are those strange cases where dark matter seems to be missing galaxies whose stars move exactly as their visible mass predicts. These are rare, puzzling exceptions, and scientists debate their origins. Perhaps they were stripped by tidal encounters with neighbors, or perhaps they represent some temporary quirk in galactic evolution. Whatever the reason, they remind us that even the universe leaves clues to its mysteries, small contradictions that invite us to look deeper. Exhale slowly now. The calm returns as you realize how much of existence hides beyond sight. Every twinkling star, every glowing nebula, every shimmering spiral, all of it rests on a foundation we cannot touch. When you gaze at the night sky, you are not looking into emptiness. You are looking into an ocean of dark gravity, an invisible architecture that cradles everything that glows. Consider this: dark matter does not clump the way normal matter does. It does not form planets or people, stars or clouds. Instead, it flows like an unseen tide through the cosmos, forming halos that only interact through gravity. Where these halos intersect, galaxies are born, matter pooling like rainwater along ridges of unseen hills. It is as if light itself depends upon darkness to find its place. In this way, dark matter is not the absence of light, but its quiet companion. It provides the stage on which the visible universe performs. Without its pull, the galaxies could not dance. Without its embrace, the stars could not stay bound. And though we may never touch it, we know it by the way it moves everything around it. Take another breath. Imagine traveling outward now, away from the Milky Way, into intergalactic space. Galaxies float like scattered islands, but between them, in the vast black expanse, The invisible web connects them all. If you could see it, it would shimmer faintly like smoke, illuminated from within. It is everywhere, silent and vast, guiding the slow migration of galaxies, ensuring the cosmos keeps its form. As scientists study the universe, they build simulations to reveal this hidden world. They use supercomputers to map how dark matter formed the first cosmic structures. The results are astonishing. The simulated universe, built almost entirely from unseen mass, matches what our telescopes observe. Where the filaments of dark matter intersect galaxies, appear exactly where the light should be. It is as though the cosmos remembers the shape of its own invisible bones. And yet, for all our understanding, the true nature of dark matter remains one of science's deepest mysteries. It could be composed of subatomic particles we have not yet discovered weakly, interacting massive particles, or perhaps ultralight axions, or something beyond even those possibilities. We build detectors deep underground, shielded from cosmic rays, waiting for a single silent collision between dark and normal matter, a faint signal in the quiet of the Earth. So far, the universe keeps its secret. And perhaps that is fitting, for some truths are meant to be sensed before they are seen. Pause for a moment in that thought, that the majority of the universe is invisible, that what we perceive as everything, the stars, the planets, the nebulae, makes up less than 5% of reality. It humbles us, reminding us that sight is not the only way to know. The cosmos speaks in gravity and silence, and we are only just learning to listen. Now, as you drift away from these invisible cities, picture yourself returning to the luminous realms, once more, to the faint glow of newborn galaxies. The first light emerging from the deep past. We leave behind the unseen scaffolding and move toward the first sparks that lit the darkness. Soon we will witness the dawn of starlight itself, the moment the universe first learned to shine. There was a time when the universe was dark. No stars, no galaxies. Only vast, cooling hydrogen gas adrift in expanding space. For nearly 400 million years after the Big Bang, there was no light strong enough to pierce that darkness. Then slowly gravity began to gather the gas into denser regions, forming the first stars, the ancient forges of illumination that would awaken the cosmos. Imagine drifting backward in time to that dawn. The light of our modern galaxies fades, the spiral arms unwind, and all we know dissolves into the faint hum of the primordial universe. It is colder now, quieter. Tiny fluctuations, imperceptible ripples in density, draw matter together like invisible fingers sculpting the unseen. Each cluster of gas begins to heat, compress, and ignite. And then, for the first time, darkness breaks. A single star flares to life. Its surface burns hundreds of times hotter than the sun's, its radiation fierce and blue-white. Soon others join it, forming the earliest star clusters. These first-generation stars, called population 3 stars, were enormous, many dozens or even hundreds of times the sun's mass. They burned quickly, living only a few million years, before collapsing into black holes or exploding as supernovae. Yet, in that brief existence, they transformed the universe. Their explosions scattered heavy elements, carbon, oxygen, and iron, into the once pristine gas, creating the materials that would one day build planets, oceans, and life. You can almost hear it, the universe, breathing for the first time, the first sigh of light spreading through endless space. The James Webb Space Telescope now peers deep into this ancient epoch. Its infrared eyes have captured faint, red-shifted galaxies, formed just 300 million years after the beginning of time. Tiny sparks flickering at the edge of visibility. Their light, stretched and softened by billions of years of travel, arrives now as a whisper from the dawn. Each photon that touches us tonight began its journey before Earth even existed. In these early galaxies, stars crowded together in turbulent, dense clouds. Gas swirled, cooled, and collapsed, giving rise to rapid bursts of star formation. Gravity worked relentlessly, merging small structures into larger ones. One day, these would become the vast spiral and elliptical galaxies that now fill the universe. The light from those first stars began the process known as reionization, when ultraviolet radiation cleared away the fog of neutral hydrogen, making the universe transparent for the first time. Light could finally travel freely. The cosmos became visible to itself. Pause for a moment. Breathe in slowly. And imagine that first morning of existence. A horizon lit, not by a single sun, but by countless distant stars, emerging all at once. Their light is still out there, streaming endlessly, through time painting the dark with warmth. What we call ancient is in the scale of eternity, still very young. Now let your thoughts drift over the shapes of those first galaxies. They were irregular, chaotic, still learning form. Some were only 1,000th the size of the Milky Way, yet within them lay the seeds of everything to come. The stars that would later merge into larger systems, the first black holes that would anchor galactic centers, and the heavy elements that would someday become dust, rock, and living breath. Science tells us that the earliest galaxies were surprisingly bright for their youth. Observations from Webb have revealed galaxies like Sears 93316, whose light began its journey just 235 million years after the Big Bang. It defied expectations, larger, denser, more evolved than theory predicted. Such discoveries remind us that even our best understanding of cosmic history is still unfolding, still open to wonder. Now consider the color of that first light. The youngest stars shone with intense ultraviolet brilliance. But after billions of years of travel through expanding space, that light has stretched into deep red, nearly infrared hues. When you look at the distant universe through a telescope, you are not seeing the color as it was, you are seeing time itself, stretched thin light, slowed by expansion. Each wavelength carries history, like a fingerprint of the universe's growth. As you breathe out, picture yourself floating at the edge of one of these first galaxies. Around you, space is not empty. It hums with the faint radiation left over from the Big Bang, the cosmic microwave background. Within that subtle glow, new stars ignite one after another, each adding to the slow awakening of the universe. And in that vastness, you realize this is the origin, not just of galaxies, but of all memory, all warmth, all possibility. What began as darkness now blooms with structure. Gravity continues to weave its quiet art, drawing galaxies together, shaping clusters, sculpting filaments that stretch across millions of light years. From this point forward, the universe will never be dark again. Every galaxy, every star, every glimmer in the sky is a descendant of that first luminous breath. Take a moment to reflect on what this means. Every atom in your body, every carbon in your cells, every iron atom in your blood was once part of a star like those early giants. You are made of the remnants of the first fires. You carry their light condensed and transformed, flowing now through living veins. When you gaze upward, you are looking not only into space but into ancestry, the universe remembering itself through you. The early universe was neither simple nor silent. It was a place of fierce creation, of constant renewal. But within its wildness, there was a rhythm, a slow harmony building from chaos. It is the same rhythm that continues even now, as galaxies form and stars are born, as black holes grow and cosmic dust drifts through nebulae like forgotten songs. The first light has never gone out. It merely travels on, and as the scene quiets again, we drift forward through time past the first galaxies, past the early clusters, toward the grand spirals and halos that now define the visible universe. We return to our own galactic home, where ancient mergers have left their traces, streams of stars, marking the pathways of memory. It is there in those remnants that we will find the story of how galaxies remember who they once were. There are memories written across the sky, faint ribbons of starlight tracing the history of our galaxy. They drift quietly through the halo of the Milky Way, curving around it like gentle waves on a cosmic tide. These are stellar streams, the fossil trails of long-lost galaxies and ancient star clusters that once moved independently through the universe. Over billions of years, the Milky Way's gravity drew them in, stretched them apart, and scattered their stars into elegant strands. What remains is not destruction, but remembrance, a record of how our galaxy grew and changed. Imagine yourself suspended above the Milky Way, looking down through its luminous spiral arms. Beyond that glowing disk, hundreds of thousands of light years away, faint arcs shimmer in the dark. Each is a path carved by time, a lingering echo of a galaxy that was slowly absorbed. Astronomers have found more than 30 such stellar streams, though there are likely hundreds still unseen. Thin, quiet bands of light threading through the darkness like threads of silver silk. The Sagittarius stream is perhaps the most well-known. It encircles the Milky Way like a ghostly belt. The remains of the Sagittarius dwarf galaxy being drawn into our own. Its stars stretch over hundreds of thousands of light years, wrapping around the sky in a faint curving arc. When scientists traced its motion using data from the Gaia mission, they found that the Sagittarius stream had not only shaped the Milky Way's halo, but likely disturbed its disk as well, rippling it like a pond touched by a falling leaf. Some believe this ancient encounter may even have sparked bursts of new star formation within our galaxy, reigniting its quiet heart. Take a slow breath. Picture those stars drifting endlessly, their orbits warped but graceful. Each one is an ancient traveler, once part of another galaxy, now a citizen of ours. Their motion is slow, beyond comprehension, completing one orbit around the Milky Way in more than 500 million years. Yet together, they tell a story of movement and memory of how galaxies merge not in violence, but in the soft patience of gravity. As we drift closer in our imagination, we see smaller trails, two streams, born not from whole galaxies, but from dissolving star clusters. Clusters like Palomar 5, whose faint stream stretches nearly 20,000 light-years. Its stars spilling from the edges of the cluster like grains of sand from an hourglass. Over time, the Milky Way's tidal pull gently teases these clusters apart, spreading their stars into long filaments that drift through the halo. Each filament carries the rhythm of its origin, the faint gravitational fingerprint of where it once belonged. Breathe slowly and let the realization settle. The Milky Way itself is a mosaic of many galaxies. Our home is not a single creation, but a layered memory of countless smaller ones. Astronomers can even read those memories through chemical tagging, a technique that traces a star's unique composition to identify the galaxy or cluster it was born in. Stars that form together share identical chemical fingerprints, like siblings from the same family. By studying them, scientists can reconstruct the Milky Way's ancestry piece by piece. These discoveries have revealed something profound. The galaxy is not a finished work, but a living record still being written. Even now, new streams form as small dwarf galaxies continue to drift into our orbit. They will one day be stretched and blended, their stars mingling with ours until no distinction remains. And somewhere among those distant threads, perhaps one day, a future astronomer will look back and trace their pattern, reading our time as we read those before us. Let your breathing soften. Imagine standing beneath a clear night sky, far from any light, where the Milky Way arches overhead. What seems to the eye like a solid river of stars is in truth the sum of countless stories. Every streak of light across that band was once part of something else, drawn together by gravity, shaped by motion, united by time. The air around you feels still, yet above you, everything is in motion. The halo of the Milky Way, its vast spherical region of ancient stars and dark matter, holds many of these streams. It is faint, diffuse, and largely invisible to the naked eye. But it is there, encasing the galaxy like a memory cloud. Within it move the relics of forgotten galaxies, ancient star clusters, and the earliest building blocks of the Milky Way. By studying their orbits, astronomers can map the invisible shape of our galaxy's dark matter halo, revealing where the unseen mass curves and flows. The stars act as messengers, tracing the outline of something we cannot see. And so the galaxy itself becomes a kind of diary. Each stream is an entry, each cluster a sentence written across time. Together, they form a narrative of merging and renewal, a story that began before the sun existed and continues still. Our solar system, orbiting near the inner edge of one spiral arm, has made more than 20 circuits around the galaxy since its formation. All the while, the Milky Way has continued to change around it, gathering, folding, absorbing, remembering. Take another deep breath. If you could see the galaxy's past as a sequence, it would look like a slow dance of light and shadow. Small galaxies drifting near their shapes, dissolving their stars, joining the collective glow. At no point does it stop. Even the quiet of space is full of motion. Even stillness holds momentum. As your thoughts settle, feel the gentle comfort of that idea that change is not chaos, but part of the order of things. The Milky Way has lived for billions of years and will live for billions more, continuing to gather and transform. And just as the stars move through its arms, so do we, circling once every 200 million years, carried on this silent journey through space and time. Now, as the last of the streams fade from view, imagine looking ahead. Far across the galactic plane, another spiral gleams faintly in the void. Andromeda, our nearest neighbor. In 4 billion years, its light and ours will intertwine, its shape merging with our own. The next chapter of this long cosmic story awaits the gentle anticipation of two galaxies destined to meet. Far beyond the quiet rhythm of our solar system, the Milky Way continues its endless turn, one slow rotation every 200 million years. Yet in that slow, majestic motion, an even grander event is unfolding. Across the gulf of space, the Andromeda galaxy, our nearest large neighbor, is moving toward us. Though it lies 2.5 million light-years away, its approach is steady and certain. In roughly 4 billion years, these two great spirals will meet. The night sky, if seen by distant descendants of our world, will become a living masterpiece, a ballet of stars, luminous and serene, played out over billions of years. When astronomers first measured Andromeda's motion using the Doppler effect, they found something unexpected rather than receding with cosmic expansion. It was approaching us at over 100 kilometers per second, about 200 20,000 miles per hour. This finding transformed our understanding of local cosmic motion. While the universe as a whole expands, gravity binds nearby systems into families, clusters, groups, and pairs that remain connected despite the stretching of space. The Milky Way and Andromeda are part of such a family known as the local group, and gravity is slowly drawing them together, like two drifting leaves caught in the same current. It is easy to imagine such a collision as catastrophic, but that is not the universe's way. Space is vast, and the distance between stars is immense, on average several light years apart. When galaxies merge, stars seldom collide. Instead, they pass through one another, pulled gently by gravity's invisible threads. Gas clouds compress, spiral, arms distort, and waves of new star formation ripple through both galaxies. It is not destruction but renewal, the transformation of structure into something calmer and more complete. Close your eyes and picture it: two galaxies facing each other across the cosmic dark. The Milky Way's spirals shimmer in blue-white light, Andromeda's in golden hues. As they draw near, their outer arms begin to stretch toward one another, forming delicate bridges of gas and dust. Over millions of years, those bridges will become luminous with newborn stars. From Earth, the night sky will change. Andromeda will grow brighter and larger. First, a faint smear, then a magnificent bloom of light spanning the heavens. The view will not be frightening, but breathtaking, a cosmic sunrise drawn out over ages. When the galaxies finally meet, they will begin to pass through each other, their shapes warping into long, graceful tails. Astronomers have seen such scenes elsewhere. The antennae galaxies, two colliding spirals, showcase the beauty of this process. Arcs of stars, curling outward, vast clouds, glowing with starbirth, all illuminated by calm inevitability. After their first pass, the Milky Way and Andromeda will drift apart slightly, then fall back again. Each encounter will blend their structures further, until at last, after several billion years, the two merge into one. The result will likely be an elliptical galaxy, smooth and radiant, its spiral arms gone, its disk transformed into a rounded glow. Astronomers sometimes call this future remnant Milkomeda, a poetic fusion of names, a symbol of unity. In that distant epoch, our sun, by then nearing the end of its life, may have already expanded into a red giant. Yet, for whatever life might exist elsewhere in this merged galaxy, the night sky will be dazzling. Instead of one narrow band of stars, the heavens will blaze with light on every horizon. The universe for them will feel intimate and bright. Breathe slowly. Think of what such a merger means not only in cosmic terms, but as metaphor. Two vast systems meeting after billions of years apart, merging in a silent, luminous embrace. There is no haste, no violence, just the steady pull of gravity, the quiet law that governs everything from falling leaves to colliding galaxies. In this way, the cosmos teaches patience. Change can take eons, yet every moment is part of its unfolding. Scientists have even simulated this encounter using supercomputers and observations from Hubble and Gaia. These simulations show the dance in exquisite detail, how the galaxies' disks will tilt and twist, how their stars will be redistributed, how tidal streams will stretch for hundreds of thousands of light years. The merger will give rise to waves of star formation as gas is compressed, creating new generations of suns that will light the future sky. And then gradually, as fuel runs low and turbulence settles, the galaxy will grow quiet again. Its stars will drift into a gentle equilibrium. The chaos, long forgotten. Let that image settle in your mind. Billions of stars, each one a point of light, slowly weaving together until there is no longer a Milky Way or Andromeda, only one calm elliptical whole. The gravitational ripples of the merger will eventually fade the new galaxy, drifting serenely within the local group. The smaller companions, the Magellanic Clouds, the Triangulum Galaxy, will orbit its massive core like quiet satellites around a single heart. The cosmos, having witnessed yet another act of creation, will continue in peace. Now pull back farther in your imagination. From afar, the merged galaxy glows softly within a cluster of others. The faint filaments of dark matter still connect them, invisible but unbroken. In every direction, galaxies continue their slow ballet meeting, merging, evolving. Each event separated by billions of years, yet united by the same law of motion. It is a reminder that even the grandest transformations happen with grace. And so the Milky Way's destiny is not an ending, but a joining. One galaxy reaching out to another, drawn together by the same quiet force that shapes all things. This cosmic embrace is a story of connection, of renewal, of light. Finding balance in the dark. As you breathe deeply, let the thought bring calm. Everything in the universe moves toward harmony, even if that harmony takes an eternity to arrive. Ahead lies another mystery, the force that allows us to see so far into these cosmic events. For it is gravity again that bends light itself, letting us glimpse distant galaxies long before we could dream of reaching them. In this way, gravity is both sculptor and storyteller, shaping not only the universe but how we witness it. And now, as the universe drifts back into silence, may your mind rest in the calm between stars. There is a quiet truth in the way the universe reveals itself. We see only because light bends. Every sunrise, every glimmer of starlight, every reflection in water is a dance of photons curved by matter. But far beyond our familiar world, gravity itself acts as a lens warping the very path of light across cosmic distances. This phenomenon, called gravitational lensing, allows us to see the otherwise invisible, to glimpse galaxies too distant and faint to be reached by even the most powerful telescopes. Take a slow breath. Imagine drifting through space, far from the Milky Way. Around you, the darkness is soft and endless. Then, from somewhere ahead, a faint distortion begins to shimmer, a halo of light bending around an unseen mass. That glow is not a trick of the eye, but the curvature of space-time itself. A massive object, perhaps a galaxy or cluster of galaxies, sits between you and a still more distant source of light. Its gravity is so immense that it bends the light coming from behind it, focusing and magnifying it like glass shaping a sunbeam. The result is one of nature's most breathtaking illusions: arcs, rings, and mirrored images of galaxies that lie billions of light years farther away. Astronomers call the most perfect of these patterns an Einstein ring, named for the mind that predicted such warping over a century ago. These glowing circles are not merely beautiful, they are windows into epochs we could never otherwise see. Light that left a young galaxy shortly after the first stars formed now reaches us because a massive cluster has bent its path just enough to bring it into view. When you look at a photograph of one of these lensed galaxies, perhaps from the Hubble Frontier Fields or the James Webb Space Telescope, you are not just looking at light, you are looking at a conversation between gravity and time. Each arc is a message from the distant past, stretched and curved, taking the long way home. The light may have traveled more than 10 billion years, bending around obstacles redirected yet never broken. The universe, patient and precise, uses its own weight to reveal itself. Inhale slowly. Let the image form in your mind a galaxy cluster like Abell 1689, containing hundreds of galaxies packed together. Their combined mass distorts the light behind them into sweeping ethereal curves. These luminous arcs are not random. They trace the hidden shape of the cluster's dark matter, an invisible framework revealed only through the behavior of light. By studying these distortions, scientists can map the unseen, tracing how dark matter weaves through the cosmos. Gravity becomes both sculptor and storyteller, its hand leaving fingerprints across the sky. Even individual galaxies can act as lenses. Some bend the light of quasars, brilliant beacons powered by black holes in the early universe, producing multiple images of the same object scattered across the sky like reflections in a hall of mirrors. When the light of these distant quasars brightens and dims, astronomers watch the time-delayed flickers between each lensed image. From those delays, they measure the expansion rate of the universe itself. In this way, gravitational lensing is not only an art of beauty, but a tool of precision, a way to measure cosmic motion across unimaginable distances. Now think of the delicacy required for such a phenomenon. The alignment must be exact. The observer, the lens, and the background source, all lying along one straight cosmic thread. Shift the angle even slightly, and the effect disappears. Yet across the universe, billions of such alignments occur naturally, producing a quiet gallery of light-bent wonders. There is no hand arranging them, no artist composing the frame, only the law of gravity endlessly repeating its curve. Let your breathing slow again. You can almost feel the serenity of these images, the elegance of light taking the long road, the patience of time itself. Nothing rushes in space. Even light, the fastest traveler, yields to gravity's gentle persuasion. In this surrender lies revelation. The universe teaches us that even the straightest path can be made more beautiful when it bends. The James Webb Telescope has begun to uncover even fainter and farther galaxies through this natural magnification. Behind massive clusters, like SMACS 0723, Webb's lenses reveal star systems that formed less than 1 billion years after the Big Bang. Without gravity's intervention, they would remain hidden forever. Instead, the universe provides its own telescope, magnifying the distant past so that we may witness its birth. In a poetic sense, the cosmos is both the lens and the light, both the observer and the observed. Breathe deeply now and imagine the grand scale of it all. Every photon that reaches your eyes has been shaped by gravity's hand, from the gentle curve that keeps the moon in orbit to the immense warping that reveals galaxies at the edge of time. The same force that binds the Earth to the sun bends starlight across the depths of space. We live in a universe that constantly shapes our vision, turning light into language and space into story. There is a certain comfort in that realization. We are not passive observers of the cosmos. We are participants in its geometry. The light we see, the light that warms us, the light that defines our world, has all been guided here through a cosmic choreography older than life itself. Every glimmer is a trace of gravity's grace. Every star, a verse in its silent poem. As the images fade in your mind, imagine pulling back, leaving behind the arcs and rings, the mirrored galaxies and halos. The light straightens again, calm and free, continuing on its way through the intergalactic sea. Gravity has done its work, revealing the hidden and connecting the distant. And from this quiet miracle, another question arises. What greater balance holds the galaxies themselves together, turning them with such smooth and steady rhythm That answer too waits in the darkness. There is a rhythm to the turning of galaxies, a quiet order hidden in motion. When we gaze into the night sky, every star we see within the Milky Way is part of a vast rotation, orbiting the galactic center like beads on a slow-moving wheel. Each one follows an invisible path shaped by gravity's patient hand. For centuries, astronomers believed they understood that rhythm. But then, in the stillness of the 20th century, a woman named Vera Rubin listened more carefully, and what she heard changed our understanding of the universe forever. Take a calm breath and imagine the Milky Way seen from afar, a grand spiral of light rotating in the darkness. You might expect that stars closer to the center would orbit faster than those farther out, just as planets close to the Sun move quickly, while distant ones like Neptune move more slowly. Yet when Rubin and her colleague Kent Ford measured the rotation speeds of distant stars, they found something extraordinary. The stars on the galaxy's edge were moving just as fast as those near the center. It was impossible, according to the physics of visible matter. If all the mass of the galaxy came from what we could see, stars, gas, dust, then the outer stars should have been flung outward into space. Instead, they held their places, orbiting steadily, as if anchored by an unseen weight. The only explanation was that something invisible, something massive, surrounded and bound the galaxy. A vast halo of what we now call dark matter. Let that idea rest for a moment. Breathe deeply, feeling the stillness it brings. The universe Rubin showed is built mostly from what we cannot see. Her quiet discovery reshaped cosmology, turning attention from the luminous to the hidden. The galaxies we photograph, the spirals, the clusters, the glittering arcs of light, are but the thin, glowing skin of a much larger structure. Around each one lies an immense sphere of unseen mass, extending hundreds of thousands of light years beyond the starlit disk. Now imagine drifting through that halo. There is no light here, no warmth, no color, only gravity's steady pull. Stars trace gentle curves within it, moving faster than they should, but never breaking free. The dark matter halo holds them all, wrapping the galaxy like an invisible cocoon. Without it, the Milky Way would simply unravel its stars, drifting into intergalactic emptiness. Instead, it endures its symmetry maintained by the silent weight that surrounds it. Astronomers have mapped this hidden structure, not by sight, but by the movement of stars and gas. Using radio telescopes, they study hydrogen emissions, charting how the outer edges of galaxies spin. Each observation draws the same conclusion: the visible mass is not enough. Something unseen must account for the missing gravity. When they model the galaxy's rotation, including this extra component, the curves align perfectly smooth and steady, as though the universe were whispering, "Yes, that's right. You've found the balance. Take another breath." Feel the wonder in that. Every time we think we've reached the edge of understanding, the cosmos offers another mystery, never harshly, but like a teacher revealing the next page of a book. Dark matter is one of those lessons. We know it's there. We see its effect on motion, on the bending of light, on the formation of galaxies. Yet its nature remains unknown. Is it made of undiscovered particles? Or does it reflect something deeper? A hidden symmetry in gravity itself? Scientists continue to search, listening for faint collisions in underground detectors, tracing subtle signals in the cosmic background. So far, the darkness remains silent, but it is a silence full of promise. In that silence lies a kind of beauty, The knowledge that we live surrounded by mystery, that even in the most studied corners of the sky, something unseen is at work guiding everything into harmony. The light of 1 billion stars depends on the gravity of this invisible mass, just as sound depends on air. Without it, there would be no galaxies, no clusters, no cosmic web. We owe the existence of structure itself to what we cannot perceive. Now imagine our Milky Way, again rotating slowly in the dark. Each spiral arm glows with clusters of stars, gas clouds and nebulae. But the shape, the grace of that turning, belongs to dark matter. It keeps the edges taut, holds the rhythm steady. The stars near the center whirl around at hundreds of miles per second, while those at the edges move with the same speed, tethered by invisible gravity. It is an orchestra of motion, held in tune by an unseen conductor. Vera Rubin once said that science progresses best when observations force us to alter our preconceptions. Her work was such a moment. Her patient observations made late at night, in the quiet of mountain observatories, changed not just astronomy but philosophy. They reminded us that reality is larger than appearance, that most of existence lies beyond what our senses can touch. She listened to galaxies, and they told her the universe was heavier than it looked. Breathe slowly again, and let that thought drift through you. There is comfort in the idea that the unseen can hold everything together, that stability can come from what cannot be measured directly. In our world, as in the cosmos, the invisible often supports the visible: love, memory, gravity, faith. The lesson is universal. The strongest forces are often the quietest. In the grand balance of the universe, dark matter provides structure, but light provides meaning. Together they form the whole, the seen and the unseen, the known and the mysterious coexisting in perfect equilibrium. That balance is why galaxies spin as they do, why clusters hold together, why the cosmic web stretches in delicate filaments across space. It is a harmony of opposites, a reminder that even the dark has its purpose. As we drift outward from the Milky Way, beyond its luminous disk and unseen halo, we begin to see the universe as a vast tapestry woven by these two threads. The next story will carry us through that diversity of form, the many shapes galaxies take as they twist, collide, and evolve. The cosmic artistry of spirals, rings, and irregulars awaits, each one a reflection of balance made visible. The universe, for all its vastness, is an artist of form. Every galaxy, every cluster, every curve of starlight is a brushstroke in an infinite canvas. Each structure carries its own quiet identity: spirals, ellipticals, irregulars, rings, all turning in silence through the dark. Their shapes are not just aesthetic. They are the frozen echoes of time, the visible result of billions of years of motion, collision, and balance. Take a slow, steady breath. Imagine yourself drifting through intergalactic space. Ahead, a great spiral galaxy turns slowly, its arms unfurling like ribbons of smoke. This is the classic shape we imagine when we think of a galaxy's stars arranged in graceful spirals glowing with new life. The Milky Way and Andromeda are both spirals, each spanning hundreds of thousands of light years. Their spiral arms are not solid structures, but waves of density where gas and dust compress just enough to give birth to new stars. Within those arms, the light of young blue stars burns bright and brief, while in the calm center, older, redder stars gather like the embers of a dying fire. Spiral galaxies are the poetry of motion itself. They spin in quiet rhythm, maintained by gravity and dark matter alike. Though they look still, each completes one rotation over hundreds of millions of years. And while that motion may seem endless, even, spirals change. As galaxies interact, colliding, merging, or merely brushing past one another, their shapes evolve. Spirals become distorted, their arms stretched into long tidal streams, or transformed entirely into smoother, rounder forms. Exhale softly. Now the spiral before you fades into something gentler, a glowing oval of light, featureless yet serene. This is an elliptical galaxy, a different kind of beauty. Ellipticals are older, quieter systems, their star formation long ended. Their stars drift in random orbits, lacking the organized rotation of a spiral. They glow with a steady golden light, the collective warmth of ancient suns nearing the ends of their lives. Some of these galaxies are small, compact, as a single globular cluster. Others, like M87 at the heart of the Virgo cluster, are giants, home to trillions of stars and supermassive black holes, weighing billions of times more than our Sunday. In these elliptical galaxies, time itself seems to slow. There are no newborn stars, no bright blue clusters, no spiraling arms, only stillness, harmony, and light, fading softly into space. Their calm is not emptiness, it is maturity. These are the elder statesmen of the cosmos galaxies that have lived through collisions and chaos and settled into quiet balance. Now breathe in again. The next form that comes into view defies symmetry. It is ragged, uneven, wild. These are irregular galaxies, systems torn and reshaped by gravitational encounters. Some are fragments of larger galaxies stripped apart. Others are young, still forming their stars scattered through clouds of gas. The large and small Magellanic Clouds, visible from the southern hemisphere, are examples of this kind, our Milky Way's small, unruly companions. They orbit our galaxy like fireflies, drawn to a lantern, leaving trails of gas and stars in their wake. Irregulars remind us that the universe is not always orderly. Sometimes, creation is rough and asymmetrical, yet even in this disarray, there is beauty. These galaxies are laboratories of birth and renewal, where gas still condenses into stars, where chaos gives rise to creation. They are the cosmic equivalent of sketches, unfinished, spontaneous, and full of potential. Take another gentle breath as we move closer to a rarer, stranger sight, a ring galaxy. Picture a luminous wheel, suspended in space, its bright outer ring glowing against a dark center. One of the most famous, the Cartwheel Galaxy, was formed when a smaller galaxy plunged through a larger one, triggering waves of star formation that ripple outward like ripples in water. The result is mesmerizing, a vast circle of stars, expanding slowly, silently, over hundreds of millions of years. These unusual galaxies remind us that every collision, every encounter, leaves an imprint. Some become barred spirals, with bright linear bands of stars crossing their cores, channels that funnel gas toward their centers, feeding black holes and igniting bursts of light. Others become polar ring galaxies, where one system orbits perpendicularly around another, forming an X-shaped cross of starlight. Such rare geometries prove the universe's creativity. Out of randomness, symmetry emerges. Out of motion pattern, out of time, form. The Hubble sequence the chart astronomers use to classify galaxies arranges these shapes from the structured spirals to the calm ellipticals and finally to the unshaped irregulars. Yet even this classification is fluid. Every galaxy can change over time. Spirals may merge to become ellipticals. Irregulars may settle into spirals. Nothing in the cosmos is static, only evolving endlessly, redrawing its lines. Now, Let your breathing steady again, your thoughts slowing with the rotation of these distant shapes. Each form tells the same story in its own language. The spirals speak of growth and youth. The ellipticals whisper of age and endurance. The irregulars and rings sing of motion of accidents that become art. And though their appearances differ, they share one truth: gravity's steady guidance and the persistence of light. From afar, galaxies seem eternal, frozen in their beauty. But to the universe, they are fleeting, brief arrangements of matter, destined to merge, fade, and be reborn. The cosmic painter never rests, blending one masterpiece into the next. We are even now living inside one of its strokes, our sun circling through a spiral arm, like a tiny spark in a grand swirl of fire and dust. As we drift away from this gallery of galaxies, let your imagination soften. The diversity of shapes dissolves into a haze of gentle light, millions of galaxies overlapping in the distance. Ahead, the next part of the journey awaits the story of how these galaxies breathe, how they burst into fire and rest in silence, creating their stars in rhythmic cycles of light and stillness. Every galaxy breathes, not in the way living things do with lungs or air, but in a cycle of creation and calm that echoes through the universe. It inhales when stars ignite, exhaling when the fires fade. This rhythm of burning and resting, of chaos and silence, is one of the cosmos's most profound patterns. The galaxies, it seems, know how to breathe. Take a slow breath of your own. Imagine a spiral galaxy glowing in the dark. Within its arms, clouds of gas and dust swirl together under gravity's pull. Where these clouds compress tightly enough, fusion begins, and stars are born in dazzling bursts of light. These regions, called starburst galaxies, can form new stars hundreds of times faster than our Milky Way. For a brief cosmic moment, perhaps only 10 or 20 million years, the galaxy flares with brilliance, like a sparkler burning bright and fast against eternity. One of the most famous examples is Messier 82, the Cigar Galaxy. Located 12 million light-years away in the constellation Ursa Major. It glows with fiery intensity. Its center is so active that it sends plumes of hot gas streaming into space thousands of light-years long. Radio waves, infrared light, and X-rays pour from it, signatures of a galaxy in the throes of stellar birth. If you could drift close enough to see it, you would find clouds illuminated from within, newborn stars huddled in radiant clusters, and waves of energy rippling outward into the dark. But even the most intense creation cannot last forever. The fuel for these stellar fires, cold hydrogen gas, eventually runs out. When it does, the galaxy exhales. The blaze dims. Star formation slows, then stops. Astronomers call this process quenching, when a galaxy falls into silence. Sometimes the cause is gentle, the gas simply used up. Other times it's more dramatic. A supermassive black hole at the galaxy's center, ejecting hot jets that sweep away the gas, halting the birth of new stars. The result is a galaxy entering a long period of calm, glowing softly with the light of older stars, its days of fire behind it. Breathe slowly and imagine this transition, the flickering bright core cooling into tranquility. The blue light of young stars fades into amber tones. The nebulae thin and disperse. Dust settles, drifting outward, like the final exhalation of a sigh. The galaxy remains alive, but quieter, content in its maturity. What was once a feverish starburst becomes a serene elliptical, steady and luminous in its stillness. Yet even silence is not forever. Some galaxies experience cycles of renewal. As they drift through space, they may encounter others pulling in fresh gas through gravity's embrace. These interactions can reignite their hearts, triggering new waves of star formation. The universe, ever patient, allows these rejuvenations to unfold over billions of years. In this way, galaxies inhale and exhale, in patterns too slow for any single lifetime to witness. Think for a moment of our own Milky Way. Though it is not a starburst galaxy, it still breathes. Near its center, dense clouds of gas form new stars quietly, while elsewhere, older regions rest in starlit peace. The galaxy's heart, the supermassive black hole, known as Sagittarius A times, is mostly calm, but occasionally flares with energy as it consumes stray gas. These flickers, though brief, remind us that even stillness holds potential, that every pause is part of a larger rhythm. Now, breathe with the galaxy, inhale with its creation. Imagine the clouds collapsing, the stars igniting light bursting outward. Exhale with its rest, the cooling, the fading, the drift into quiet equilibrium. Feel the symmetry of it, the ebb and flow mirrored in your own breath. The universe, from the smallest atom to the grandest galaxy, follows the same pulse expansion and contraction activity and repose, life and stillness. Astronomers sometimes describe galaxies as ecosystems. They live, they change, they age. Their energy flows from one form to another, gas into stars, stars into dust, dust into new stars again. Even death feeds rebirth. When massive stars end their lives as supernovae, they scatter heavy elements, carbon, oxygen, iron into space. Those elements seed new generations of stars and planets. From the ashes of one life, countless others begin. The cosmos is not wasteful, it is endlessly regenerative. Take another long breath. Feel how the rhythm of this truth settles into you. Every light in the sky, every glimmer we see, is part of this cycle. What we call destruction is merely transformation. What we call silence is only a pause before renewal. In this way, the galaxies remind us that endings are not final. They are preludes to creation. Far across the universe, astronomers have observed entire clusters breathing in unison. Within them, some galaxies blaze with starbursts, while others sleep in peace. The light from these distant systems reaches us as a blend of tones, some bright and blue, others golden and still. It is a cosmic symphony of breathing, each galaxy contributing its own rhythm to the larger harmony. Now, in your mind's eye, zoom outward. See thousands of galaxies suspended in space, some aflame, some dim, all turning slowly. Their collective glow is the heartbeat of the universe itself. It is calm yet alive, changing yet eternal. If you could listen instead of see, you might hear the hum of this vast respiration, the inhale of creation, the exhale of time. And as you drift farther still, you notice that this pattern, the breathing of galaxies, extends beyond them. Clusters form and fade, superclusters grow and dissolve. Even the fabric of the cosmos expands and will one day relax into stillness. The universe itself breathes, though its cycle is measured not in years but in eternities. Breathe once more with it. Let the vastness bring peace. The galaxies you have imagined are not distant abstractions. They are the ancestors of our existence. The carbon in your body, the calcium in your bones, the oxygen in your lungs, all were forged in those earlier breaths of fire. You are part of the universe's rhythm, a single note in its endless song. And as this motion slows and quiets in your mind, picture the Milky Way again. It glows softly, its arms turning its stars pulsing in calm unity. The fires within burn steady, no longer fierce but warm. From here, we will drift outward again, to the great cosmic neighborhoods that surround us, to the structures that bind galaxies together in vast communities of light and space. The Milky Way does not drift alone. It is part of a community, a quiet assembly of galaxies that travel together through space, bound not by proximity alone, but by gravity's patient tether. Astronomers call this region the local group, and within its 100 or so members lies a portrait of cosmic kinship. Here in this small pocket of the universe, galaxies cluster like families around a hearth, each with its own character, motion, and light. Take a slow breath and imagine this neighborhood as it appears from afar. The Milky Way glows near the center, a soft spiral of starlight wrapped in its dark halo. Not far away, by cosmic standards, shines Andromeda, slightly larger, slightly brighter, already pulling gently toward us through the invisible thread that will one day unite us. Orbiting around them are smaller companions, like the large and small Magellanic Clouds, glowing wisps of stars and dust that drift like luminous lanterns around our home. Beyond them, dozens of dwarf galaxies trace faint loops through space, their motions forming a delicate three-dimensional choreography around the two great spirals. The local group spans about 10 million light-years, its members moving in a slow communal dance. Most of its mass is concentrated in just 3 galaxies: Andromeda, the Milky Way, and Triangulum, a smaller spiral thought to be interacting with Andromeda's outer halo. The rest are diminutive dwarfs, quiet collections of stars, held together by dark matter, often too faint to see, even through powerful telescopes. Yet these small companions play an essential role. They are fossils of the early universe, remnants of the first galaxies that formed after the dawn of light. Studying them is like reading the earliest pages of a cosmic diary. Breathe again and imagine floating gently among them. The view is serene. The Milky Way and Andromeda face each other across the gulf, their spiral arms faintly glowing in the thin intergalactic mist. Around them, the Magellanic Clouds shimmer softly, trailing streams of gas, the Magellanic Stream that stretch halfway around the sky. These rivers of hydrogen, stripped by gravity and motion, will one day fall inward, fueling new generations of stars. Even in silence, galaxies feed one another. The local group itself is not isolated. Beyond it lies a larger congregation, a family of families. Together with nearby groups and clusters, we belong to the Virgo supercluster, an immense network of galaxies spanning more than 100 million light-years. But even that is not the end of the structure. The Virgo supercluster is part of an even grander flow, the Laniakea supercluster, a colossal region containing over 100,000 galaxies, all connected by filaments of dark matter and drawn toward a distant point of gravity known as the Great Attractor. Inhale, slowly. The scale expands, but the peace remains. The further you drift, the more the cosmic web reveals itself, a network of glowing nodes and delicate filaments connecting galaxies like neurons in a vast mind. Where the filaments meet, clusters form. Where they stretch apart, great voids, open expanses of near-nothingness, spanning hundreds of millions of light-years. Even emptiness, it seems, has structure, a geometry defined by absence as much as by light. Our own local group moves gently through this web, carried along by gravitational currents. Though the universe expands, these threads keep clusters and groups bound together, their motion shaped by the unseen framework of dark matter. In this way, gravity acts like a tide, pulling the galaxies subtly toward regions of greater density, guiding them along invisible rivers through cosmic space. It is a motion too slow for eyes to perceive, yet one we are always part of our solar system, drifting through the galaxy. Our galaxy, drifting through the group itself, gliding through the supercluster. Pause for a moment in that thought. The Earth, your home, turns beneath your feet at nearly 1,000 miles per hour. The solar system orbits the Milky Way at over 500,000 miles per hour. The Milky Way itself moves through space at nearly 1,000,000 miles per hour, relative to the cosmic background. And yet, you feel still. You feel safe. The quiet you sense beneath the stars is real, even as you are carried along through these layers of motion. The universe moves in silence. Astronomers sometimes call the local group a cosmic family, and the term feels right. Within it, galaxies influence each other's growth, exchange gas and stars, and share a common destiny. Dwarf galaxies often orbit larger ones, like satellites, their orbits stretching into streams as they are slowly drawn in. Sometimes their stars escape entirely, becoming part of the halo of the larger system. Other times, two small galaxies merge, forming a new one altogether. The process is slow, but its outcome is connection, each member leaving an imprint on the others. As your breath steadies, picture how this structure reflects a deeper truth. Just as galaxies are bound by gravity, we are bound by relationships. Each life orbiting others, each connection shaping our own trajectory. The local group is not only a physical space, but a metaphor for belonging. No galaxy moves in isolation. No light shines entirely alone. Now drift farther outward. The filaments of Laniakea stretch across your view, their clusters twinkling faintly like constellations of galaxies. Beyond them lie others, regions without names, their light still traveling toward us after billions of years. You realize that what you see is not just the present, but a layered memory of time. Every photon, every glow, is history arriving now. As the image softens, return in your mind to the Milky Way. You are back within its arms, among its stars, orbiting its calm center. The Magellanic Clouds glow faintly on the horizon, and the night sky hums with quiet unity. From this small corner of infinity, you belong to a structure so vast that its edges may never be known, and yet within it you are home. And as we prepare to travel still farther to the horizon beyond which even light cannot return, let the serenity of belonging settle within you. The galaxies around us drift not in chaos, but in harmony. The universe, in its immensity, remains one single connected whole. There is a horizon even light cannot cross, not because of walls or barriers, but because the universe itself is stretching faster than light can bridge the distance. Beyond that, threshold galaxies drift away so swiftly that their glow will never reach us. They are not gone. They are simply moving beyond the edge of visibility, beyond what the cosmos allows us to see. Take a deep breath. Imagine the night sky as it truly is not a flat canvas, but a living, expanding sea. Each point of starlight you see has traveled for millions or billions of years to reach your eyes. Some of the galaxies that once shone toward us are now gone from view, their light forever stretched into invisibility by the accelerating expansion of space. The farther we look, the more we gaze into the past, until at last we reach a horizon where the past and future blur a limit beyond which time itself seems to dissolve. This boundary is called the cosmic event horizon. It marks the distance beyond which light emitted today will never, in the infinite future, arrive at our galaxy. As the universe expands, distant galaxies move away, not through space, but with space carried outward by the stretching of the cosmic fabric itself. It is not their speed that denies us their light, but the ever-growing distance between. In this way, the cosmos quietly separates its parts, like islands, drifting apart on a swelling ocean. And yet this horizon is not a wall, it is a whisper. The light from those galaxies still exists, still travels, but grows weaker, redder, stretched thin by the very space it crosses. Over billions of years, their glow becomes infrared, then microwave, then vanishes into wavelengths so long that they blend with the background hum of the universe itself. The cosmos doesn't erase its stories, it folds them gently into silence. Exhale slowly and let that thought rest within you. What we see when we look up at the night sky is not the universe as it is, but as it once was. Every glimmer is a message from the past. The Andromeda galaxy we see tonight shines as it did 2.5 million years ago when early humans first raised their eyes toward the stars. The light of the most distant galaxies captured by the James Webb Space Telescope began its journey more than 13 billion years ago, when the first structures were forming. Each photon is a time traveler, a fragment of history still finding its way home. One day far in the future, much of that light will fade. As space continues to expand, galaxies beyond our local group will slip beyond our reach one by one. To future observers, the universe will appear smaller, emptier, lonelier. The great cosmic web we see today will be hidden beyond the horizon, and the night sky will belong once more to a single island of stars, our merged Milky Way galaxy, drifting through an endless dark. It will not be a sad ending, though. It will be peace, the universe returning to its own quiet equilibrium. Breathe again and feel how the idea of that distant silence softens the mind. Even now, as galaxies recede, the universe remains whole. The laws that shape it, gravity, light, time, continue their gentle work, weaving new stars, guiding new worlds, nurturing the same cosmic rhythm that began at the dawn of everything. The horizon is not a loss, but a boundary of wonder, a reminder that not all must be seen to be understood. As you drift closer in thought, picture the cosmic microwave background, the faint afterglow of the Big Bang. It is the oldest light we can ever observe, stretched over 14 billion years into a uniform field of warmth, only a few degrees above absolute zero. Beyond it lies the unobservable universe, vast and unknowable. Yet the light of that first fire still touches us, bathing every corner of space in its subtle glow. The universe remembers where it came from, even as it moves beyond our sight. Let that realization bring comfort. The same expansion that carries galaxies away also allows new worlds to form, new stars to shine. Nothing truly disappears. It only transforms, moving from visibility into memory, from energy into quiet. Like a song fading into silence, the melody remains in the mind long after the sound is gone. Pause and imagine looking out across that final horizon. There is no edge, no boundary, only the soft dimming of light. Galaxies stretch thin their shapes, dissolving into faint smudges, until only darkness remains. But in that darkness, there is calm. The stars that remain nearby continue to shine. The warmth of the cosmic background still hums. The fabric of existence still vibrates with quiet energy. The universe, even in its solitude, remains alive. In this vision, there is something deeply human. We too face horizons, moments where we cannot see beyond what time allows. We too lose what drifts out of reach, yet carry its memory within us. The universe teaches us how to accept the impermanence of sight, how to find peace in the unseen. It reminds us that nothing truly ends, not light, not time, not the stories carried between the stars. As you take one last long breath, picture yourself turning away from the horizon. Behind you lies the living universe, the galaxies still glowing the nebulae, still breathing the stars, still singing in quiet radiation. Ahead lies only stillness, but not emptiness. The cosmos, infinite and eternal, continues to hum softly as it always has. You are part of that hum. Every atom in your body was born from starlight that once crossed the void. The same forces that shape galaxies guide the rhythm of your heartbeat. The same light that fades beyond the horizon once shone through you. To exist at all is to be woven into the same story, to share in the same gentle ending that is never quite an end.